can be used to describe the geometric shape below. So the first name in question is a quadrilateral, and a quadrilateral is literally any closed shape that has four sides, and this is definitely a closed shape that has four sides, so it is definitely a quadrilateral. Next, we have to think about whether it is a parallelogram. A parallelogram is a quadrilateral that has two pairs of parallel sides, where in each pair they're opposite sides. And in this case, if you look at this side over here, it forms a 90-degree angle with this line, and this side over here also forms a 90-degree angle with this line over here. So these two sides are parallel, and then you can make the exact same argument for the other two sides. This line up here forms a 90-degree angle with this side, and so does this side forms a 90-degree angle with this line right over here. They form the same angle with this line. They're parallel. So this side is parallel to that side right over there. So this is definitely also a parallelogram. Next, we ask about a trapezoid. Now, a trapezoid is interesting. Sometimes a trapezoid is defined as any quadrilateral having at least one pair of parallel sides. Sometimes it's defined as having only one pair of parallel sides. So let me write this down. Trapezoid. There's a debate here. It's not completely settled. Some people say at least one pair of parallel sides. That's one definition, one possible definition. The other one is at exactly one pair of parallel sides. And this becomes, which definition you pick, actually, it depends. How we answer this question depends on which definition for a trapezoid we pick. Now, the one that people most refer to is actually this one right over here, exactly one pair of parallel sides. So the trapezoid that most people, when you think of a trapezoid, they think of something like this, where this side over here is parallel to that side over here, and those two are not parallel. But sometimes you'll also see this at least one pair of parallel sides, and so this would include parallelograms. It would be inclusive of parallelograms because parallelograms have two pairs of parallel sides. But I'm going to go with this definition right over here, exactly one pair of parallel sides. This has two pairs of parallel sides, so I will not call it a trapezoid. But it's always important to clarify what people are talking about, because some people might say a trapezoid is at least one pair of parallel sides, and if we used that definition, then we would call it a trapezoid. So it really depends on the definition that you're using. Now let's go on to rhombus. So a rhombus is a quadrilateral where four of the sides are congruent. Four of the sides are congruent. So a rhombus will look like this. All four sides have the same length. They're not necessarily at right angles to each other. This figure over here, we have two pairs of sides that are the same length, but there's no information that tells us that this side is equal to that side or that this side is equal to that side. So we can't make the claim that this is necessarily a rhombus. We don't know for sure. If someone told us that this length is equal to that length, then things change. But for the sake of this one, we're not going to go with the rhombus. A rectangle is essentially a parallelogram that has four right angles. And we already established this is a parallelogram, and it also has four right angles. 1, 2, 3, 4. So this is a rectangle. Another way to think about a rectangle is opposite sides have the same length, and you have four right angles. So this is definitely a rectangle. A square, a couple of ways you could think about a square. You could view a square as a rhombus with four right angles. So if you were to kind of straighten it out a little bit, it's a rhombus, so all the four sides are the same, and you have four right angles. That's one way to think about a square. Or you could view it as a rectangle where all four sides are congruent. But in either case, you have to have all four sides be congruent in order to be a square. And we already established when we ruled out this being a rhombus that all four sides here are not necessarily congruent. You have two pairs of congruent sides, but we don't know whether this side and this side are congruent. So we cannot call this a square. So it's not a square, not a rhombus, not a trapezoid by the definition we picked, which is the less inclusive version where you say exactly one pair of parallel sides. It is a quadrilateral. It is a parallelogram. It is a rectangle.
How can I organize all of these shapes? In this lesson, you will learn how to create a hierarchy for quadrilaterals by using their properties. Let's review. We know how to classify polygons by their sides and by their angles. For example, we know that a quadrilaterals have 4 sides and 4 angles. Parallelograms have 4 sides and 2 pairs of parallel sides. We can classify special parallelograms by whether they have congruent sides, and we can classify them by their angles. Rectangles are parallelograms with right angles. And rhombuses and squares are also parallelograms, but they are a special type that have congruent sides. A common misunderstanding is thinking that when we put shapes into categories, they can only fall into one category. Not true. For example, a square is a very specific name, but it's a special type of parallelogram and a special type of rectangle. Sometimes we think that a square only belongs in the category of squares. In reality, squares are also parallelograms, quadrilaterals, rectangles, polygons, and rhombuses. Let's take a look at a graphic organizer that can help us understand the relationship between polygons. This will help us understand how to organize shapes into hierarchies later in this lesson. Polygons are the closed shapes that have sides, and quadrilaterals are polygons with 4 sides. Parallelograms are a special kind of quadrilateral. They have 2 pairs of parallel sides. Why are the rhombus and rectangle inside the parallelogram? That's because they're both parallelograms, but a rhombus is not a rectangle, and a rectangle is not a rhombus. Why are there squares in both the rectangle and the rhombus? Because squares fit into both separate subcategories. Where would we place a kite? The kite has 4 sides, but does not fit into any other subcategory. It does not have 2 pairs of parallel sides like all of the other subcategories. We're missing a common quadrilateral, a trapezoid. Trapezoids are not as easy to place in our organizer. There are 2 definitions of trapezoids, and the definitions, or its attributes, will change where we place the trapezoid. We all agree that a trapezoid has 1 pair of parallel lines, so a trapezoid cannot be a parallelogram. Some mathematicians use the definition that a trapezoid has only 1 set of parallel lines. We would place it with the kite. It's a quadrilateral, but it isn't in the subcategory of parallelograms. Some mathematicians use the definition that a trapezoid has at least 1 pair of parallel lines. That would mean that a parallelogram is a trapezoid because it has at least 1 pair of parallel lines. It has 2 pair, and that means it has at least 1 pair. As you can see, trapezoids would be a larger subcategory that would include rectangles, rhombuses, and squares that all have at least 1 pair of parallel sides. So a trapezoid would include parallelograms, rectangles, rhombuses, and squares. Our graphic organizer would be much different. Let's use what we know about the attributes of quadrilaterals to fill in this hierarchy. What do all of the shapes you see have in common? All of the subcategories you see have attributes that make them part of the polygon category. Another special quadrilateral that does not have 2 pairs of parallel sides are kites. A rectangle has 2 pairs of parallel sides, so it would be part of parallelograms. A quadrilateral with 4 congruent sides and 2 pairs of parallel sides would be a rhombus. A quadrilateral that has properties of both a rectangle and a rhombus would be a square. In this lesson, you have learned how to create a hierarchy for quadrilaterals by using their properties.